The Broads is a mosaic of clay and peat soils. They store a huge amount of carbon and they're a sponge. And when they're drained for agricultural development, all of that carbon tends to go up to the atmosphere, and we don't have that storage capacity in the floodplain that's so important for the Broads National Park.
Peat soils accumulate under waterlogged conditions in which there's no oxygen. When we drain them, we're introducing oxygen. It allows the bugs in the soil to eat the peat, convert it into carbon. So the deeper the water table is, the greater the greenhouse gas or carbon emissions.
Peat generally accumulates about 1 millimeter per year. This is around about thousands of years of efforts. The peat at the top, so these layers are the one that are the decomposed one, because they have been experiencing the drying cycles all through the years. But as we go down to the bottom, these layers have still their plant structure intact, and they have been like preserving carbons over the years. And if they stay wet, they will continue doing so in the future as well.
We're here at the Langley Abbey estate, and here with me today is Horsey from UKCEH. Horsey, can you tell us a little bit about the peat monitoring equipment we've got here?
Yes, Andrea. So here we have 2 peat cameras, and with the peat cameras we are trying to monitor the peat surface elevation, how much it moves up and down, responding to changes in the hydrology. This is our peat camera that sits on top of a stool, and the stool is anchored into the peat surface. It's anchored by 10-15 centimeters. We also have an antenna, and the antenna allows the system to send the data to a cloud service in where we can retrieve the data and make it publicly available to everyone. We have a special ruler that we have designed ourselves, and it has Aruco markers, and those Aruco markers are special codes. Our camera can detect where they are, so we can calculate the distance in pixels and in millimeters from those markers to the surface. We can also measure water table depth using a pressure transducer sensor that sits inside this piezometer. It's about 2 meters into the soil. It will allow us to determine whether the peat is in good or in bad condition depending on where the water sits. And also peat subsidence and peat motion is completely related with water table changes, so they basically track each other. With the flux tower, we can measure the carbon balance of the ecosystem, so we can determine whether the soil is losing carbon or if we are storing carbon and it's being accumulated into the soil.
So Cranfield University have produced a water table model, so they've cast across the landscape, and that will describe the amount of carbon emissions and also describe the amount of nature, the amount of water that we've got in ditches. How important will that be for the estate?
Of course, you can look into any one of these ditches on a given day and see the height of the water table, but it doesn't always give an accurate reflection of the water table in the field itself. And so having that modelling, we have a much clearer understanding as to where we currently are, but also what we would need to implement to get where we want to be.
So Horsey, what do you hope this project might achieve?
We are hoping to develop a monitoring, reporting and verification tool, and this is something that could be used for carbon credits projects, restoration projects. But in the short term, we are hoping to develop a web app, and then you can actually see what the site is doing, how much the peat has moved up and down, what's the water table depth, what's the soil temperature. And then we are also hoping to help policymakers to take decisions regarding peat condition, and then help them develop policies according to the needs of nowadays.
If farmers can raise their water tables, which in some peats in the country can be as deep as 2 metres, then we reduce the greenhouse gas emissions very quickly from these soils. And with very high water tables, like we'd find under some of the classic broadland fens, we can have almost 0 greenhouse gas emissions. We can switch off the peat soils as a source of greenhouse gases.
Close to the coast in the Broads National Park is the Horsey estate, and here we're working in partnership to look at a pioneering wetland farming project about the future of farming in Britain's largest protected wetland.
What motivated me to use this land? Really, it was enthusiasm of the Broads Authority, and it's a particularly good site for treating orange, dirty water coming into the Broads.
So we've planted over 20,000 plug plants with the support of some fantastic local volunteers. We're taking water from the river and then we're flowing it through these 5 compartments, like one of the ones behind me here. By opening the sluice, the water flows through. You can see that it's full of ochre, which is this naturally occurring iron compound. We want to filter this out, and we'll do that by flowing the water through this series of reed beds. We're going to be harvesting the reedmace here, and then working with our partners, we're going to be turning that into construction materials such as insulation or pressed board. So really looking at whether we can add value to this crop.
We're working with scientists and policymakers to get paludiculture adopted into agricultural policy and create that network of expertise and knowledge that can be translated into other projects.
So I'm really hopeful here that this site will show how you can make commercial reed or typha growing possible, which would be great.
We're hoping that we can demonstrate how we can re-wet these peaty soils to reduce carbon emissions, and then also how we can grow reed and reed mace for really innovative construction products.
It's not an easy option, but it's a fantastic way of preserving the nature which evolves around peatland.
The main thing I'm hoping this project will achieve will be a successful case study of how farmers can raise their water tables and achieve lower greenhouse gas emissions.
So Henry, what do you hope will be achieved for this project?
So our aspirations here at Langley Abbey is to see a Yare Valley landscape, indeed a wider Broads landscape, teeming with wildlife, all whilst delivering those vital ecosystem services. But of course, it all starts and ends with how we manage our water table and how well we can conserve our peat soils.
This is about rethinking our relationship with nature and finding new ways to work with the changing landscape of the Broads.